Okay, so now we're going to look at solving quadratic equations, and factoring is going to be one of the methods we're going to use to do that. First, we're going to look at when we solve. Notice this is a linear equation. The power of x is 1. So typically when we solve, the goal is to isolate the variable. So if we have 3x minus 4 equals 13, we get x by itself on one side of the equal sign. So we would add 4 and then divide by 3, and we would get x equals 17 divided by 3. That's called isolating the variable. That will work with linear and some quadratics. We're going to talk about which quadratics you can do that on in the future. But for right now, when we have these quadratics, we're going to try to factor them. Something like this. So we have this equation. Now it's a quadratic equation. Okay, so what happens is if we try to isolate the variable or get x by itself, we subtract 3 off both sides. But now we're stuck because we have an x term and an x squared term. I'm going to start naming these terms. That's the quadratic term because it's the squared. That's the linear term. And that term we call the constant term. You need to know those names. It's because of the power of x in each term. And when there is no x, we call it a constant. When the power of x is 1, we call it linear. So that's our linear term. That's our quadratic term. When you have both the quadratic term and the linear term, you can't get x by itself. So that's the problem that we encounter. So you can't solve, say it this way. Because there is both the quadratic and linear term. So we can't solve by isolation. We have to try a different method. So we're going to get into the zero product property here. Just remind you of what it is. This is how we're going to solve these by employing the zero product property. So it says, this is saying this is kind of the property. If a times b equals 0, then what conclusion must be true? Either a has to be 0 or b has to be 0. That's because this is a product, two things multiplied together. And when a product equals 0, that means each factor can be 0 to solve. So here's the zero product property again. This is a product. So the conclusion that must be true is that x plus 5 must be 0 or x minus 2 must be 0, because this is the first factor, that's the second factor. So when either one is 0, then the whole thing equals 0 by the zero product property. Okay. Then once we know each factor is equal to 0, what must x be? Well, we know for the first one, if x is negative 5, that's going to make that 0. And if x is positive 2 on the second one, that makes it 0. So like these would be your solutions to this equation here. If I plugged in negative 5, I get negative 5 plus 5 times negative 5 minus 2 equals 0. Negative 5 plus 5 here is 0. So I get 0, and then negative 5 minus 2 is negative 7. So I get 0 times negative 7 equals 0. That's true. That makes negative 5 a solution. Similarly, if we plug in 2, I get 2 plus 5. And then times 2 minus 2 equals 0. Well, 2 plus 5 is 7. 2 minus 2 is 0. 0 times 7 is 0, so that's also a solution. So those are our two solutions. And this is how we're going to solve quadratics. We need to apply the zero product property. So that means our quadratic must be equal to 0, and the left side, or the other side with the x's on it, must be in factored form so that it's a product. Okay, so to solve a quadratic equation, we want to first make the equation equals 0. And that's different than what we're used to for solving. Like I said before, for linear equations, we want to separate the x's and the numbers. Get x's on one side, numbers on the other side. It's called isolate the variable. You've been doing that for a long time. This is kind of the complete opposite to start this off. You want to get everything to one side of the equal sign. You want to zero out one side and make everything equal to 0. So instead of separating x's from numbers, we're putting all the numbers and all the x's on one side. Once we have it equal to 0, we're going to factor the side that has all the stuff. That does two things. That sets us up for zero product property. It makes this side a product. This side of the equation turns it into a product. Things times each other. It makes the other side 0. So then we can apply the zero product property because we have a product that would be equal to 0. So then the last step would be to solve each factor. So we can set each factor equal to 0 to find all solutions. All right, so let's practice this. Solve by factoring. So step 1, set the equation equal to 0. It's already done. Check. Equals 0, right? Now factor the left side. So now I'm looking to factor this guy. This one might be easy enough to come up with combinations. I got 2x and I've got x. I know it's got to be, well, I don't know, but I'm going to try, I'm going to try 2 and 3, and we'll try negative, positive. So 2x, I got to check it now. 2x times x is 2x squared. Negative 2 times 3 is negative 6. Now I got to check the mixture. Whoops. 2x times 3 is 6x, minus 2x is 4x, so that doesn't work. We got a 4. So let's try other things that multiply to 6. Let's try a 1 and a 6, and we'll go with a negative 1 and a positive 6. So 2x times x is 2x squared, negative 1 times 6 is negative 6. Let's check the middle. This is 12x, and that's minus 1x. So I'm getting 12x minus 1x is 11x. So that's not working. I'm going to try to switch the 1 and the 6 and see what happens there. 2x times x is 2x squared. Negative 6 times 1 is negative 6. Let's check the middle. 2x times 1, so that's what we did before. So I'm having trouble coming up with the combinations. So when that happens, we can always split the middle term. So we're going to have 2x squared and negative 6. And then we're going to split the middle term into the linear term into two linear terms. And the way we do that is we do a times c. So 2 times 6 equals 12. Oh, it's a negative 6. So 2 times negative 6 is negative 12. And then we look for the factors of negative 12 that add to negative 1. So it's going to be 4 and negative 3 or negative 4 and 3. Which one adds up to negative 1? That's going to be this one here, negative 4 and 3. So that's how I split the middle term. I make two linear terms, negative 4x plus 3x. Now I can factor by grouping. I group the first two together and I see a common factor of 2x. So I get x minus 2. Now I group the second two together. I see a common factor of 3. If I divide out of 3, I get x minus 2. Now I common factor again. So I've got my two terms here separated by that addition. I notice they have a common factor of x minus 2. So that's what I'm going to divide out. And what do I have left when I divide it out? I have 2x plus 3 equals 0. So there we go. It's now factored. So step 2 is complete. I have it equal to 0. I completely factored the other side. So now I can apply the zero product property. That means if a product, which this is because of the multiplication, equals 0, then the solutions will be when the first factor is 0 or when the second factor is 0. So I make little mini equations. And now I can solve these because these are linear equations, notice. That's why we wanted linear factors. I know how to solve linear equations well. I separate the x's from the variables. One solution is x equals 2. Here I'm going to subtract 3 off both sides, divide by 2. And my other solution is x equals negative 3 halves. All right? Let's try the next one. Zero product property. So first we got to get it equal to 0. So I'm going to add 3x to both sides. So I have 5x squared plus 3x equals 2. Then I'm going to subtract 2 off both sides. So I get 5x squared plus 3x minus 2 equals 0. So I'm setting this up for zero product property. I have it equal to 0. Now we've got to completely factor the other side. Again, this is one where a is not 1. I'm going to look for combinations. I'm going to try 5x and x. And then things that multiply to 2, negative 2 have to be like negative 2 and 1. Let's try this combination. So I just got to check the mixture. I know the first and the last are okay because that's why I picked those numbers. So 5x times 1 is 5x. Negative 2x times negative 2 times x is negative 2x. 5x minus 2x is 3x. So there we go. I was able to get this one right away through combinations, so I don't need to try this whole split the middle term to get there. So now that it's completely factored, I can apply zero product property, which says I have a product equaling 0. It's a product because it's multiplication. So if I set each factor equal to 0, those will give me my solutions. These factors are linear factors, so I go ahead and solve. I add 2 to both sides. I divide by 5. There's one solution, x equals 2 over 5. The other one, I subtract 1 off both sides. There's that solution. Okay. Here's another one. So we like to have our x squared to be positive. So when I make this equal to 0, I'm going to add 2x squared to both sides. So I've got 2x squared plus x equals 6 now. Now I'm going to subtract my 6. And on the left side I get 2x squared plus x minus 6 equals 0. Okay, so again, here's one where a is not 1. There's no common factor that I can do. So I'm going to look for combinations. I know it's got to be 2x and x. For minus 6, it's going to be similar to the first one we did. The only difference is instead of minus x in the middle, we now have a plus x. So it's going to be almost the same, but the signs are going to be different. So we factored this one into x minus 2, 2x plus 3. It's going to be the opposite. So the signs are going to change. It's going to be 2x minus 3. And then x plus 2. And let's check that the middle parts work. 2x times 2 is 4x, minus 3x is 1x. So it works. So now zero product property says that if I set each factor equal to 0, that's a 0, and solve, I'll get my solution. So I add 3 to both sides, I divide by 2, that's a solution. I subtract 2 off both sides, that's a solution. Alright, let's check out this guy. Ooh, it's already set up to go. I've already got it equal to 0. Now I just have to factor this side. A is 1 now. So this is a nice one. This one we should be able to find this by combinations relatively easy. It's got to be x and x. Now I'm looking for numbers that multiply to negative 15. So I'll go 1 and negative 15, negative 1 and 15, negative 3 and 5, 3 and negative 5. So I just keep looking for these combinations, ones that add to negative 2. It looks like this one's going to. 3 and negative 5. So it's going to be x plus 3 times x minus 5. Now it's set up to apply the zero product property. I have a product equaling 0. So I set each factor equal to 0 to solve. Everyone is so loud outside in the hallway. So I get x equals negative 3 or x equals 5. Let's try this one. It's not ready for zero product property. I've got to subtract 12 off both sides. So now I have it equal to 0. Now I have to factor the left side. Again, x is 1, a is 1, so we know it's got to be x and x. We're looking for two numbers that multiply to negative 12 but add to negative 1. So multiply to negative 12. We've got 1 and negative 12, negative 1 and 12. We've got negative 2 and 6, 2 and negative 6. None of those add to negative 1. We've got negative 3 and 4 and 3 and negative 4. That adds to negative 1. There's our winner. So it's x plus 3 times x minus 4. Now I can apply zero product property because I have a product. There's multiplication equals 0. So I set each factor equal to 0 and solve. Those are my solutions. Okay. Oh, this one's already set up. We just need to factor. Ooh, I noticed this one's a difference of 2 squares. Those are my favorite ones to factor because they're so easy. The square root of x squared is x. The square root of 9 is 3, so that's where my x's and my 3's come from, and then I know it's plus and minus. I can now apply zero product property. So I get x equals negative 3 on this factor, or x equals 3 on that factor. This one is not ready to go. We have to make it equal to 0, so I subtract 25 off both sides. This is also a difference of 2 squares, so I know it's going to factor into 2x and 2x, 5 and 5, and I change the signs. So now I make each factor equal to 0 and solve. So I get 2x equals 5, x equals 5 halves. Or I subtract 5, I get x equals negative 5 halves. Those are my two solutions. Let's move on to the next one. So now I'm going to, I got to set this one equal to 0. I want my x squared to turn out to be positive, so I'm going to subtract x squared off both sides. So I'm going to get 2x squared minus 7x minus 6 equals negative 9. I'm going to add 9 to both sides. Minus 7x plus 3. When I add 9 to both sides, I get plus 3. Now I'm looking how we're going to get this to factor. A is not 1 here, so I'm going to try some combinations. And I get this. So I set each factor equal to 0 and solve. So I get x equals 1/2 on this guy, or x equals 3 on that factor. This one, again, I want to end up with the positive x squared, so I'm going to subtract x squared from both sides. So I'm going to subtract x squared off both sides to keep my quadratic term positive. Nice. And then I'm going to subtract 4x off both sides and get minus 3x. Subtract 1 off both sides and get a minus 4. This one, a is 1, so factoring should be pretty easy. Look for combinations that multiply to negative 4 but add to negative 3, so that's going to be negative 4 and positive 1. Set each factor equal to 0 and solve to get my two solutions. Okay, that's how we're going to solve using factoring. Good luck.